Hello, everyone, and thank you for joining us. We're currently live from the OH Hinsdale Wave Research Lab at Oregon State University. And today we're going to be simulating some destructive wave and storm surge impacts on elevated coastal infrastructure, just like those you'd see from Florida to the Carolinas.
So we're going to be utilizing the NSF Natural Hazards Engineering Research Infrastructure, or NERI funded directional wave basin for these experiments. And the data collected from this test will be used to better understand how elevated buildings respond to hurricane forces.
No signs of significant structural damage were seen during the 8 trials yesterday.
So today, testing started since earlier this morning at a water depth of about 3 feet or 0.91 meters and 3.25 feet, just under 1 meters. And so we're resuming now, as you can see on the screen, under current conditions of 3.5 feet or just over 1.07 meters of water depth and 20 centimeters or around 8 inches of waves just now at 1 o'clock. So this will be trial number 17.
So the houses we were testing at are actually at 1/3 scale. And this type of scale has never been performed in this wave basin. Closest we've got is what, 1 to 6?
Pretty small.
Yeah, so this is double the amount and allows for more accurate data. The orange house that you see on the right in this camera view is elevated 3.5 feet off the basin floor, which corresponds to the design needed to withstand a 100-year flood. The green or teal house that's further back in the left here is located 1 foot higher at 4.5 feet off the basin floor. This represents the design of closer to the 500-year flood.
So the current wave conditions that you're seeing will be running for about 10 minutes, followed by a few minutes of break, and then an increase of 5 centimeters to a wave height of 25 centimeters. This process will be repeated until waves about 35 centimeters high will be tested for about 10 minutes.
So we just got a great question in the chat asking about what type of data is being recorded. So attached to the houses, the orange house specifically, are pressure sensors on the bottom of them, as well as a pressure sensor at that white front door, and then one on the back side as well. Those pressure sensors inside the house are also on the greenhouse. These are recording pressure and amplitude of the waves. What's also being recorded, if you see all those QR codes or maybe even reflective little spheres, these help the more structural oriented people understand the deformation and changes that are occurring while the waves are hitting it.
And then after each of the tests, we have LiDAR scans that are happening, and then we have additional measurements that are happening through drone footage and through hydrodynamic testing that's going to happen after the experiment is over.
I'm next going to show a little bit of the inspiration behind this project. It was inspired by observed failures of coastal residential structures in Florida as a result of storm surge and storm wave conditions. A storm chaser named Max Olson was able to capture the following footage of some failure we expect to see here today in Fort Myers, Florida, during Hurricane Ian in late September of 2022. So just pay attention to that red house you see there, and you can see just how quickly that storm surge can increase. So right there, the house very clearly tilted off of its foundation. And here it's dislodged. How are the houses anchored to the seabed? So this wave basin has what's called unistrut, and it's basically metal struts running through the entire thing that the houses can be bolted down to. So each pier of the house is bolted down, as well as a through bolt running through those piers to ensure that those don't move. So here's the general skeleton of the house, and then you can see the placement of those internal structural supports.
And in the back, you can see the construction of the foundation as we put together the piles and the ways that those things are connected to one another.
And in between, we're going to show you just some footage of once those individual pieces of the houses were built, we had to get them into the basin. So we have a short little montage of that.
Part of our research has been conducting.
Sorry to interrupt you, but we just saw a little failure there under that first floor window.
A little.
Small amount of failure.
Okay, so we're getting a lot of questions about the scaling and about the different materials that we use. And so what happened here is that whenever we're scaling down the houses, we can't scale down necessarily material properties. And so what we can do is scale down things like the spacings, like was mentioned by Chad. And so we conducted several tests on the different coupons or the different components of the house at different spacings for dry and wet tests to see if we could match the strength of the house to what is realistic.
Okay, if you were watching closely there, you may have seen some additional destruction to that same window that got punched through. And there are internal supports on that side. I think we anticipated the other window to go first. But just goes to show how unpredictable these things are. And especially once you have one slight failure. All right, for those of you still with us, we just got some pretty severe damage. Some indentation to the right of a structural support inside. Oh, and there it is again. Big wave. Okay, you can see that second story starting to buckle there. So we just lost the front door of the orange house. And there goes most of the paneling that was left. So now we're going to start to see some debris in the. So currently the back door is gone as well as the panel right next to it. And testing has begun. We are going to stop testing for today. As Mr. Rob Bolton noted earlier, this would definitely be considered insurance loss and loss of structure. So this is a failed structure.
So thank you for joining us. It was really interesting.
Yeah, very interesting. Thank you for all the insightful questions. really enjoyed getting into the depth with you all and seeing just how damaging some of these waves can be.
Oh, there it goes.